Hi, this is Ayoung, the presenter of T9. Our topic is about unsupervised landmark detection for video generation. I will do the presentation in this order: introduction, proposed method, experimental results, and conclusion. Firstly, this part shows some previous works about unsupervised key point detection method. They predict key points using a designated template or shape of images, so those have a fatal limitation about inconsistency of extracting key points. You can see each key point in each frame indicates a semantically different area in this picture. So we proposed a downstream task, generative model, generating source file images to take key points. In this process, we use first-order motion model as baseline, which is an image-to-video generation model. First-order motion model takes source image and target image as an input, manipulates the source image following target image's action as an output. However, this model also has a problem that the task is still random. There is no loss or module to make key point detector more consistent, so we add loss for generated motion with ground truth motion. Now, this figure is our overall structure. Model consists of two parts, motion model and generation model. Motion model predicts a dense motion field from a driving frame to the source frame, and generation model renders an image of a source object moving as provided in the driving video using a generator network. Motion model's objective is to estimate the backward optical flow from the driving frame D to source image S. We can get predicted optical flow between two frames in motion model, and we compare to the ground truth optical flow when generating image. We used backward optical flow because backwarping can be implemented efficiently in a differentiable manner using bilinear sampling. Motion model consists of four steps. Firstly, we use the key point detector, extracting heat map of key points, and then center of heat maps are selected as key point. Using this result, backward optical flow is obtained, assuming an abstract reference frame R. Finally, we can get the dense motion representation. The T D to S comes out. Dense motion is a part to get entire dense motion prediction between two frames S and D. In the dense motion, we can get heat maps of each key point in pose-based stats by subtracting two heat maps centered in TR to D and TR to S. The heat maps and the transformed images are processed in UNets, and finally we can estimate each local transformation and final dense motion prediction. The second module is a generative module that creates altered image following driving images action based on predicted optical flow and ground truth optical flow. You can find out the generated source style image, which is same as driving frame image. In this whole process, we use perceptual loss, equivariance loss, discriminator loss, optical flow loss. Perceptor and discriminator is used in generation, GAN, and we use the optical flow loss compared to the ground truth and the predicted one. You can see the key points located in two dataset, deep fashion and VOX. In the images, we can find the same color of the key points, semantically has the same meaning in the same parts. Also, our features outperforms in AKD metric contrast to other existing method, for example, the X2 phase monkey net and first order motion model. AKD stands for average key point distance, which means the distance between detected key point from pretended key point. This is the firstly suggested indicator by author of first order motion model. Lastly, at the conclusion, we used key point detection based on first order motion model, and the motion between two frames is represented by key point and local affine transformation. Generating manipulated source image following target images action, and our contribution is that we set downstream task in advance and detect model driving key points, which is optimized to reconstructing target image. And by focusing on movement of key points using first order model, we can expect it to have more consistency contrast to the existing method. Thank you.